other will be in this direction, and finally what they are doing, they are balancing each other. Therefore we are saying summation of forces is equal to 0. Then we saw some beam. So this was a simply supported beam. We saw the number of reactions. In a hinge, there is 2 reactions. In a roller, there is 1 reaction. So there is total 3 reactions here. And we can write 3 equations of static equilibrium. That means to find 3 unknown, we have 3 equations. We can do that easily. Therefore, it is a statically determinate structure. In this one also, this was a cantilever. One end is fixed, one end is free. In the fixed end, there is 3 reaction, and in the free end, obviously there is no reaction because it is free, no support. So again, you have 3 reactions and 3 equations of static equilibrium. So the unknown forces or the reactions, these are the unknown forces or reactions that can be found using equations of static equilibrium only. So again, statically determinate structure. Then we saw this one. Here we have 3 roller support. Now what will happen if we have these 3 roller support? Because the rollers are providing restraints only in this direction, it is giving a force only in this direction. That means it is preventing the downward movement. It cannot prevent the lateral movement. So whenever the beam or structure experience a slight amount of lateral force, it will move in this direction or in this direction as the force acts. Okay, so it is not a stable structure. Okay, if slightest amount of force comes, it will move in this direction. Then we saw this structure. This is called a propped cantilever. One side is fixed like a cantilever, another side is free in case of cantilever, but here there is a roller joint, and this is known as propped cantilever. In propped cantilever, we have 1 reaction, 2 reaction, and 3 reaction in the fixed side, and 1 reaction in the uh, roller support. So that means we have 4 unknown forces or reactions, and how many equations we can write? 3 equations we can write. So 4 minus 3, we have 1 extra. So we say that this is statically indeterminate by degree 1. In the indeterminate stable structure, 1 is the degree of indeterminacy. Then this degree of indeterminacy, if it is a statically determinate, then degree of indeterminacy is 0. We have 3 unknown, we can write 3 equation. Degree of indeterminacy is equal to 0, or it is a statically determinate structure. Then again, if the unknown forces are 5, we can write 3 equations. Then degree of indeterminacy will be 5 minus 2. Sorry, 5 minus 3. So it is statically indeterminate of degree 2. Similarly for other number of unknown forces. Okay, this is for simplest case. But what will happen if the unknown forces are less than 3? Okay, we'll see. Before that, another example. Okay, here we have a hinge support. Here we have a roller support. So we have 3 unknown, 3 unknown. We have 3 unknown. How many equations we can write? We can write 3 equations. We have 1 member, we can write 3 equations, and that means this is statically determined. Then we have another structure here. Here, fixed joint, roller joint, and roller joint. So in fixed joint, 3 unknown and 1 for roller joint. So we have total 5 unknown forces. 1 member, we can write 3 equations. So we have more unknown forces or reactions than equations of static equilibrium. That means it is statically indeterminate. By how much? 5 minus 3 equal to 2 by degree 2. Then these are some pin connected structure. Okay, pin support means hinge support. So these are going to be statically indeterminate. We have three, this is fixed, so we have three unknown forces here. We will have two here, we are just separating it out. We have two here, but they are ultimately they are the same. This force is going to be equal to this force, but in the opposite direction. So ultimately they are going to be single set of forces, and we have two unknown here. So here we have three, here we have two, and here we have two. So we have 3 plus 2, 5, 5 plus 2, 7. Okay, how many equations we can write? We have two members, we can write 6 equations. Again, it is statically indeterminate. Then here we will again come back and solve this. Okay, these things. I'm just going through basic stuff. Here we have three members. Here we have two unknown, two unknown, two unknown, and this is a fixed support. So we will have three unknowns. 2, 4, 6, 9 unknowns. We have three members. We can write three equations, so it becomes statically determinate structure. Then this is a frame. Okay, a building frame can be idealized or simplified into something like this. So we know this. So here what will happen? How many unknown forces are here? Here you have unknown forces at the support. Here you have unknown forces at the support. Here you have unknown forces in the member. Here you have unknown forces in the member. Now, how many equations you can write? Here you can write three equation, and here you can write three equation. You have two loops. We'll study again. Two members or two loops here. Okay, where we can write down our equations of static equilibrium. So we can write down a total of 3 into 2, 6 numbers of equation, and unknown forces we have 9. That means it is statically indeterminate by degree 3. Okay. Then again another frame. So here we can write 3, here we can write 3, here we can write 3. So we can write a total 9 equations of static equilibrium. How many unknowns are here? We can calculate. There will be 18 unknown reactions. Okay, 3 here, 3 here, 3 here, 9 here, here, and here in this loop. So 9, 3, 3, 3, 9. Here it is 12, here it is 15, and here it is 18. So 18 unknown forces or reactions are there in this frame, and we can write 9 equations of static equilibrium. So 18 minus 9, it is statically indeterminate to the 9th degree, or simply 9. Okay, this is how it goes. Okay, and most of the structure that we are using are statically indeterminate. Obviously, the statically determinate conditions that is required for minimum stability. A structure will be stable if it satisfies the conditions of statically determinate structure. Okay, if it just satisfies the condition of statically determinate structure, then it will be stable. If it is more than that, then we have some factor of safety in the stability. Okay, I'll explain again. Okay, so now the thing is that we have seen that, for example, if the number of unknown forces are more than equations of static equilibrium, then it is statically indeterminate. If it is equal, then it is statically determinate. What happens if the number of unknown forces are less than equations of static equilibrium? For example, we have a beam here. Okay, if we have a beam, pardon the drawing, I'm using mouse, and we have two roller support. So how many unknown forces are here? One unknown force and one unknown force. We have two unknown force, three equations of equilibrium. So that means unknown forces are less than equations of static equilibrium. then what will happen? This structure is called as not stable, unstable. Okay, we can just see from the mechanism of this structure, then because it is a roller support, it is not able to prevent lateral movement. Slightest amount of force in this direction will make the beam go in this direction, right? So there is unstable, statically determinate, and statically indeterminate. In a statically indeterminate structure, it may be like that. If we remove one or two members, it will still be stable. Okay. Why? Because to be stable, the minimum condition is to be satisfied the statically determinate structure. Extra member, it becomes statically indeterminate. I don't know if you're getting the point, but we will come back again and discuss. This was just a brief overview of entire statically determinate and indeterminate. Then again, we have to go inside and we have to find out the number of determinacy, indeterminacy for trusses and beams and frames again. Now, for example, in this case, okay, in this case, again, another example of stability and instability. See, in this case, what is happening? The supports here are like this, but in this case, the support is like this. So if the support is like this, the reaction will be like this, okay? So if we apply a force here like this, the resultant is in like this. So this is a condition of instability. It will do what? It may uh, allow the structure to come in this direction, okay? But in this case, because it is here in this direction and the applied forces are, these forces will be applied here and these forces will be, reactions will be applied here, okay? Forces applied here, reactions are not parallel, okay? Reactions are not parallel. Therefore, this condition, this one is stable, okay? One moment. Sorry. Okay, this is one condition. If the number of reactions or unknown forces are less than 3n, okay, 3 into n is your members. Whatever is the number of members, number of the structural members in the total structure, that much equations of static equilibrium we can write. Per member, 3 we can write, right? So if the unknown forces are less than the number of equations of static equilibrium, then it is unstable, one thing. And again, it is unstable if member reactions are concurrent or parallel of some component and forms a collapsible mechanism, okay? This one is important, collapsible mechanism. Even if the number of unknown forces are more, but it forms a mechanism, okay, a situation where the beam may collapse, the structure may collapse, then also it is unstable, okay? So in this case, it is always true. If R is less than number of equations of static equilibrium, then it is always unstable, no doubt. But even if it is greater than equal to this number of equation of static equilibrium, we will have to check mechanism. It is stable or not. If it is stable and equal to the equations of number of static equilibrium, this is statically determinate. If it is more and still stable, then it is statically indeterminate. Okay, if it is unstable, then we will not bother finding out what is determinacy, indeterminacy. Why? Because if it is unstable, it is not a structure, it is not serving its purpose.